all right. Let's get this show on the road. It is 7:02. Hello, everybody. We've already made a partial announcement about the new shirts modeled by yours truly's. Yeah, if you want a shirt, $20. At the break, if you want to come up, Venmo, cash. That was a small intro, but first thing is first, Go Spurs Go. Woo! Tonight, starting in an hour and a half. And the second thing was going to be the shirts, but that was first. So, hello, we're here. It's May, day after Cinco de Mayo. I hope everyone is not hungover, or if you are, thanks for coming. I hope you're not melting. I am. I've been wet just all day long because it's so humid. Profuse sweat, just all day long. And then, nice crowd tonight. Nice crowd tonight. It's good to see a nice full house again. How many first-timers out here tonight? KOT. Got a good handful? Got a good handful? I know, Kyle. I knew it was your first time again. Good for you for the first-timers. You didn't have to wait a year and change for new shirts. You showed right up and got new shirts, so that's nice. We have an old shirt. It's a small, but it's half off, $10, if anybody wants it. It's the old logo made by Christine. She was a previous host a couple years ago. It's got a nice beer mug with the galaxy in it, and the Alamo. And then I guess everyone else has been here, done that, been out here to Astronomy in the chat before. Cool, thanks for coming back. Michael is having an aside with Adam real quick.
Let's see how my microphone sounds. Well, what are we?
You jumped the gun a little bit.
Oh, I did?
I didn't even introduce. I got so caught up with the shirts. I'm just hyped up on the shirts. My name is Aaron. Hello, everybody. This is Michael. All right. Erica's down here, sitting down. She helps out with, obviously, everything. Adam is running online, doing IT, helping with the sound and the video online, and making sure everyone, my mom and Michael's dad, can watch successfully. And then Sam, Sam's here in spirit. He made the trivia. We'll see what's in store for us.
He actually made it this time.
Yes, he did actually make questions. We verified there is an answer key, but we'll see what the questions are, I guess. It's always a doozy with Sam. And then Brian's not here tonight. Jasmine's going to be up in a little bit doing astronomy in the news. And Thomas is online, helps out with socials a little bit. And the OG Tracy herself, she's not here tonight, but she's always here in spirit. And I think that's everyone. Got to go down the list. Now, back to what Michael was saying for the first timers. What is Astronomy on Tap?
Well, it is a worldwide, global phenomenon. Right there, yeah. I always say, don't I always say worldwide? Sam really doesn't listen. It's a worldwide phenomenon, although it looks like we lost one in Chile. Or maybe that's left over from my April Fool's thing, and maybe Sam has it out for Chile. Oh,
yeah. Cool. But if that one's gone, there is one more. There's a new one in Helsinki now in Finland.
Oh, yeah.
The new satellite just launched.
It'd be right there where the red dot is. Yes, we are the yellow dot. What makes us so different and special from the rest? Well, he didn't change this either. God damn. Samuel Hart Helio.
He even acknowledged it. He was like, what's all this?
Okay, for those of the first-timers, last month's AOT fell right on April Fool's Day, so we had a little fun with the crowd, because this one does on April Fool's. It's bled over to this month, unfortunately, so I don't have...
Now
exactly, it's the secret to
it's opposite day now.
Yeah, we'll just say, we are fun. We are... this is restricted. We're interactive because you will all have the chance to ask our speakers questions, and we always encourage it and welcome it. And we'll have the phone number on at the. Oh yeah, there's the number. Yeah. lastly, we like to have fun because we do the trivia at the end, but we also have a few traditions throughout the course of the night as we will go through that hopefully you all will leave, if it's your first time, wanting more, and if you're used to coming, hopefully you still keep on coming. Please check out our socials if you haven't already, and then do sign up for our mailing list. The QR code will show up later again at some point. Yes, thank you. Sorry about this mishap. To keep on track, monthly we welcome photography. If you take any beautiful photos of the sky, we welcome it. We want to showcase it. And today we have our very own Ethan Chappell's photo of Jupiter. Beautiful. And you can see the big red spot. This was on March 1st. Where is this from? Wow, from your backyard? Oh, and a moon. Callisto, wow. This is really something else. Jupiter is the biggest planet of the solar system, so you can get some really great photos of it as a result. Thank you very much, Ethan. And of course, if any of you all want to send us one, there will be information later tonight to let you know how. And that'll also be the email where you complain to Sam at as well.
Erica sent a message in our group Discord to Sam. All right, our schedule for tonight. First up, we're going to have Everything is Bigger Than Texas, a tour of the solar system, not a sentence you hear very often in Texas. And then we're going to have Astronomy News with Jasmine Singh, and then closing out, we're going to have Space Weathering on the Moon with Austin Patridge, and of course, our iconic astronomy trivia presented by Samuel Hart. Please, always remember it's Samuel Hart. All right. Clicker, please. We're next. All right. This is why I was asking about the HDMI. Usually it's up on the TV. However, we don't have that. So if you would like to mark it down somewhere, I'll give you a couple seconds and stall while perhaps you write it down. If you don't want to write it down, that's fine. I will come back up at the end of Allison's talk. All right. Dr. Allison McGraw is a planetary scientist who studies asteroids and meteorites to understand how planets formed in the early solar system. Her research combines laboratory measurements and telescope observations to connect rocks that fall to Earth with asteroids still orbiting the Sun. She is currently a postdoctoral researcher at the Lunar and Planetary Institute in Houston. And for the first timers out here tonight, we have a tradition. We have a drinking word. When the word is uttered, what do? You take a swig. Allison, what is your drinking word tonight?
Size.
Drink responsibly. All right, everybody, let's give it up for Allison.
All right. Thank you, Erin. Thanks to all the AOT. I have performed at the Tucson Astronomy on Tap, so I'm excited to now be presenting here in Texas for you all. All right. Yes, a sentence that maybe contradicts what you typically hear in Texas. Okay, so I'm going to take you through some scale sizing in our solar system, a little bit of our tour of the solar system, if you will, compared to our loving Texas, of course. So I am a postdoctoral researcher at the Lunar and Planetary Institute. It's been a part of NASA since NASA was NASA. It was instigated at that same podium that JFK said, by the end of the decade, we'll get a man to the moon and we'll also make the Lunar Science Institute. And now we're the Lunar Planetary Institute. So we actually have a public library that's accessible for everyone to come access all of the great JSC, Johnson Space Center, free, open to the public. Because you're a taxpayer, right? You pay your taxes. Okay, you can come to the library because it's all paid through 1/17 of your penny, of course. All right, so I'm half Texan, but I promise I'm fully qualified, okay? And actually, right when I got into San Antonio today, someone told me, oh, yeah, you look like a McGraw. Melt my heart, right? So I get to spend time both behind the microscope and behind the telescope, and when I can in the field. So here I am at two impact craters, one that's really, really old in that Permian Basin that we love here in Texas and the Sierra Madera. This is clocking over 300 million years old, and you might think there's not much in West Texas, but there is an old impact crater. And also more famous is Meteor Crater in northern Arizona. And if you're lucky, you get to hike to the bottom, which is really great and rewarding. And I'm what you call a non-traditional student. Just kidding. All right, so I've been through undergraduate and graduate school and put myself through college. All of these great things got me to where I am today, from the Camp Peak National Observatory, from behind a planetarium, to the different ambassador work that I've got to do through OSIRIS-REx, which returned the first American asteroid sample, which is also on display in Houston if you make it over there, through my NASA grants, and then now through this Encompass and URI Fellowship at the Lunar and Planetary Institute. And so we'll use the state of Texas, and geologists will tell you to never use a human scale, and maybe someone would tell you to never use a Texas scale, but I'm going to do that tonight because it's astronomy on tap, and we get to use whatever scale size we would like to. All right, so how big is the state of Texas compared to objects in our solar system? And again, what is a really good scale size anyway, right? Okay, so this is actually taken from some astronauts as they get to pass over Earth. There's Houston all lit up for you, and there is a really great repository from astronaut photography that you're able to access through part of the NASA.gov series of galleries and whatnot anyway. Space is huge. There's trillions of galaxies, which then contain each billions of stars, which then might have maybe millions of planets around it, and if they're really good planets that have really hooked up resources like magnetic fields, atmospheres underneath those magnetic fields, and oh, by the way, a rotating molten magnetic core to make that magnetic field, maybe thousands of those scattered about. But we're really going to be focusing on the smaller scale. This is the Hubble Deep Field, a famous image where we did a long exposure and one tiny arc fraction scale size of the sky, okay, and let Hubble have the lens and the shutter open for some time and obtained this image. And it's only been upgraded with the bigger telescopes that we have now. All right, so Texas, right? Texas, home to probably a lot of us. So let's use the max east-west. So I'm going to go from El Paso to Orange, and this is just under the 800 marker, 773 miles wide, right? This becomes our one Texas for our scale size. And you already know that, all right? And so we got to start with Earth, right? So here's another astronaut photography. So some of these astronauts are really good, stable, with really nice lenses pointing out through the port windows, taking a nice picture of Texas and maybe the not so nice polluted Galveston over there. We see why it's always gray, right? Anyway, so we can fit about, 10 Texases, right? 10 Texases across our home planet, home of Texas. Now, when we look up at the moon, hopefully you get to see it through intermittent clouds over Texas. But one of the most prominent features that you get to see is one of the more younger, and everything on the moon is old, but relatively speaking, one of the younger impact craters, Tycho, or Tico, however you feel to pronounce it for the night, which is, when you often view it, that really, really bright impact feature, and it's got a nice central pit, so if you get a telescope, some of us have some astrophotography, it sounds like, it's got this amazing central pit, which is similar to the physics when you drop that bowling ball in a bathtub and you have that water rush up to that central point. The rocks do that for a fraction of a second, too, and make what we call a central pit. And it's actually best to view the moon when it's in a half-moon phase, or the terminator, and you can get shadow detail from those central pins as well, convincing that there's no flat moon, okay, because if it's flat, there wouldn't be shadows, right? So the scale size of Tycho crater, okay, is only a fraction of Texas, okay, so it's quite small, but notice that the impact rays are quite large, and this is as that material is excavated and thrown out at various velocities depending on the material, and, well, there's no atmosphere here, but this ejecta is thrown out. And so Tycho crater is a great just binoculars or regular eye viewing object. The sun. Okay, so the sun is where we jump up in scale size a little bit too much, okay? So these sunspots essentially could eat Texas for breakfast, right? So we have also up in the top right, I'm going to have a scale of how many Texases you can fit to each object. But for the sun here, notice I have it in 8 light minutes. So, when you get to feel the sunlight on your skin, that took 8 minutes when it left the photosphere of the sun. The photons might be much older due to the random throughout the sun, but once it reaches the surface, it moves at the speed of light and meets us here at the Earth 8 light minutes away. Okay, but the scale size of the Earth is down here on the bottom. All right, so we can see from this Solar Dynamics Observatory. So there's space weather, and NASA even has an entire sector under heliophysics. It's a whole other side of NASA where they just study the sun, and they are constantly looking for sunspots and huge releases of solar flares that can affect our telecommunications and geosynchronous orbital satellites. And once upon a time, used to be able to catch our typewriters on fire. Okay, I guess there's trivia also at the end, but, I brought some swag also, so maybe you want to win some of this. All right, so, oh no, okay, I was told first year undergrad physics, but in planetary and astronomy, some physics, we love order of magnitude, right? Hand wavy, tilde, order of magnitude, okay? So, who's seen this sign also? Who's driven across Texas? One person, okay, there's another sign that's in Beaumont that conversely tells you, in Beaumont that conversely tells you, how far away El Paso is. And so it's a really silly thing, but say you were going, 80 miles per hour across the state of Texas, which you can for a lot of it. Let's think about some order of magnitude. So does anyone... we could think, it's 800 miles across, and we can maybe go 80 miles per hour. Does anyone want to give a guess? I heard some murmur of something on this. 100 years? Okay, yep. Order of magnitude, 133 years. So, yeah, it's basically 100 years, right? Okay, yeah. Yes, all right, I got a moon poster for you, okay? So, yeah, this is, way too long, right, to be driving to the sun. Okay, just setting the scale. All right, so some people love Mars, right? We've been sending a lot of different spacecraft to Mars, landers on Mars, rovers on Mars. In fact, Mars is the only planet within NASA that has its own special office. Go figure, right? There's not even an Earth office. What? There's a Mars Exploration Office. And one of the most prominent features that actually on a good night, if you get lucky with a backyard telescope or even maybe a big small telescope, something maybe a feet, 1 to 2 feet wide, a fraction of a meter, you can actually sometimes see clouds stuck over this volcanic feature. Okay, so it's 17 miles tall, and this crater, so this is not an impact crater at the center, it's of course a volcanic collapsed crater from the eruptions. It's got these amazing huge scarps. It's a very wide, low topographic feature, and it's speculated that if you were hiking on Mars, you actually wouldn't even know you were hiking up Olympus Mons for some amount of time because it's so gradual. But we can fit like 2 of those across Texas, okay? And that is surely one of the largest features on Mars. There's a large canyon on Mars, and then this huge volcanic feature, but only a fraction the size of Earth. All right, so this is where I get to live. I get to characterize the meteorites that land here, or if we're lucky enough to send a spacecraft and bring something back, to ground-based telescopes that get to look at asteroids, both in optical light, infrared light, radio light, radar pinged from our surface. And I want to show off the eyes of the solar system for what's really a dwarf planet. And that'll come up later a little bit, dwarf planet. Ceres is actually very much still a fraction of Texas, okay? And that is the object in the asteroid belt. So, all right, so Texas is finally a little bit bigger than something, right? Bigger than Tycho Crater, bigger than the asteroids. But eyes on the solar system is really neat. You can see updated data layers and real-time displays. So this was series just this afternoon, so that I got a live view of that. And that's NASA Eyes on the Solar System. So, you know, things are big, really big. You might just not believe how big it is, right? But especially when you see the images of from the James Webb or the Hubble images, hopefully that can start to give a sense of that scale size. All right, so we've got some larger planets entering the zone here. So Jupiter has a public kind of designated camera called JunoCam. So members of the public could essentially say what they wanted to target, and a lot of folk then took it and ran with it and did a lot of image processing with it. It's just really neat to see. And this was done as like a kind of a combination graphic, and then I shoved a bunch of Texases down there. All right, so there's 13 Texases down there. And Galileo, when he pointed a refractor telescope at Jupiter, actually identified the Great Red Spot as well. So it's been going, man, and we don't know really when it's going to stop. And it does wax and wane, and it also gets a little bit more orange and a little bit more red from time to time. All right, Saturn. So the vortex that is the North Pole of Saturn is not, it's sort of like a hurricane, but the these are essentially like 4 jets that are tightly wound together. And the seasons are each about 7 years on Saturn, and things are just moving a lot more slow. So we don't know how long-lived this is, but it's could be hundreds of years old as well. We first saw it. Voyager was able to sort of see an edge, just the edge of it, and then Cassini, which when we were done with Cassini, we threw it in Saturn like a trash can because we didn't want to contaminate some of the moons of Saturn for astrobiology. So there's interesting icy rock mixtures on some of the moons out in the outer solar system. So it was a really amazing NASA spacecraft that ended in a really sad big teardrop. But a lot of great time-lapse images, and also rings were discovered, more moons were discovered, and the rings are still, the Cassini team is actually still processing all of that ring data, actually. All right, time from the Uranus jokes, right? Oh, no, I worked in the planetarium. It's Uranus for the kindergartners, okay? But I'm not going to give you the South Pole. Sorry, okay? South Pole is pointed away from the sun here, where the sun don't shine. Okay, this is the North Pole, and this is a newer-ish discovery. This is actually from ground-based radio wavelengths from the Very Large Array. Has anyone ever seen a radio dish array? Maybe you have to drive through nowhere, New Mexico? Yeah. So this is from the VLA. And this is a polar storm, and I got a little tiny Texas way in there. It looks like there's a dot on the screen, but okay, so really huge, right? We can fit 41 Texases across, and poor Uranus and Neptune really get the butt end of everything, okay? They barely had flybys, okay? We've had no dedicated orbiters that sat in orbit around the planets and got a lot of really high-resolution detail. Yet again, the Voyagers kind of scathed by. Sometimes some ground-based observations do pretty good. But it's super understudied, as well as the moons out there. Could have a whole lecture just on that alone. One of the interesting features, like the Great Red Spot for Jupiter, is the Great Dark Spot. You can fit 10 Texases across that right there. And again, this is actually a Voyager image right here, but the smallest cloud structures that you're able to make out is still 31 miles wide in size. All right, is Pluto a planet? How many times do we get asked this? All right, so the International Astronomical Union, we love acronyms, right? The IAU got together, and it was like 5,000 or 6,000 votes on this in like 2007 or 8, and the vote was no, but it really is. It's going to complicated. Okay, it's actually a dwarf planet. Okay, so just like Ceres and many objects in the Kuiper belt, which is a second, bigger, badder asteroid belt beyond where Pluto hangs out, and Pluto orbits the sun much more inclined or up at an angle from our average of the solar system, and so sometimes it cuts off Neptune, sometimes it goes a little further out, as do many of the objects, or the KBO is another painful acronym. So we did have a flyby in 2015, the New Horizons spacecraft, and they were looking for a lot of craters, and then they found not a lot of craters, but they found a lot of nitrogen ice mountains. And these are on the same scale size mountains of here on Earth, maybe a little bit more west. You know, we don't have as many mountains here in this part of Texas, but these are nitrogen ice, and their flow features, they're actually active. Oh, and then with Ceres, we do a lot of comparisons because, you know, flying to things is really expensive. And so a lot of Ceres ice rock mixtures are also applied for how we understand Pluto and its companion, Charon, or Charon, or Charon, however you like to pronounce that one as well. All right, I hear Charon. Okay, we can have a whole vote on that. Okay, so hopefully you can remember some of these sizes. Okay, so Olympus Mons versus Ceres, that dwarf planet, or the Sputnik Planitia, that was the nitrogen ice mountains we just saw on Pluto, or Texas. Anyone want to, I think at the back of hand? Olympus Mons? No, but that is about twice. Remember that actually Texas won this one. Yeah, we did get about 2 Olympus Mons in Texas. All right. Yeah, it was just that feature. Yeah. I remember Ceres was even small. So, yes. Praise the cosmos, I heard one professor tell me. Okay. So just 3 important takeaways. Hopefully I haven't bored you too much, and we had a few drinks in there. All right. Texas is huge, but space is bigger, right? The planetary features that we get to see, at least in our solar system, actually rival the scale size of the states that we get to live into. And then I hit the wrong button at the end? Ooh, okay, I thought I did. Scale is what? Actually kind of humbles us, right? Yes. So take a look up at the night sky and ask me questions. I also have a meteorite. If you ask me, I'll let you hold something from space. Yeah, thank you. Oh, that's right. There was an actual, thank you. Thank you so much. Yeah. And for my folks that answered the questions, I got the posters for you too, so.
All right, Erin's going to put the number up for us to remind folks, but I do have a question already for you, and it is, how many times have you driven across Texas?
How do you know me? Wow. Let's see. When I lived in Arizona, I was driving to San Antonio, and now I live outside of Houston, and I drive back to buy meteorites back in Tucson at least once a year, holidays, overall, and then as a child, and then across the I-10 completely from one side to the other, and so did my dog. My 17-year-old dog made it across the entire I-10 as well. Oh. I would say, like, order of magnitude, like 100. Yeah, I would have to say. That's too many times across Texas. Making me question my life decisions.
What's your favorite solar system object?
Okay, so right now it's asteroid 16 Psyche. There is a spacecraft that is also named Psyche, just to make it a little more confusing. But there's been a lot of speculation of this particular asteroid. Some folks thought it looked like a nasty metal mixture, or maybe it's pure metal, or maybe it's metal with some carbonaceous mixtures. So the spacecraft, I forget when it gets there, if there's any Psyche enthusiasts, maybe 2028 or 29 or something like that in the next few years. 29? Yeah. So how do you make an impact crater in solid metal? Because you think if it's molten for that even fraction of a second before it recrystallizes or rehardens, that it would maybe just go to a flat state. These are low gravity objects, but you look at the artist renditions, even on the NASA Eyes of the Solar System, pull up Psyche, they got a bunch of crazy looking craters on there that we don't actually know fully exist in metal form yet. So it's our first metal-rich asteroid mission. So right now, Psyche, and there's a bunch of art related to Psyche too. A little plug for the Art of Planetary Science and also just the Psyche mission. There's even an entire undergraduate course at Arizona State University. It's a little bit far from us, but there's an entire Psyche art endeavor. You can go look at the art galleries also online, which is really cool.
Very cool, thank you.
Yeah.
Do you know how many Texases would be the distance from the sun to the edge of the Oort cloud?
Yeah, I kind of stopped us at Pluto. Let's see, the Pluto, wait, does it go back? Are they all one sequence? No, they're not. Okay. I didn't put it on there. I'm sorry. I changed my slide format, so that's why I don't do that. It's because the format of the image needed to be bigger. Let's see, but at Neptune here, so we're at 3.6 billion Texases, and then I would say at probably 5 billion Texases is where the Oort cloud would start more. I think, yeah. And then that goes out probably another probably another 1,000 million, other billion Texases, probably wide. It's pretty widespread, if I recall correctly. Yeah,
Wow.
good question.
It's impressive. Let's see, this one, do we know why that storm on Saturn looked like a hexagon?
So there is actually some lab testing. I don't remember the lab or facility, I'm sorry, but under these kind of low density, there's no solid surface. So one thing is that there's no solid surface. It's like this column of different gas, different species, slightly different densities, but I understood it to be low density. There's also a joke that if you put Saturn in a bath, it leaves rings because it's lighter than water. So these gases under the low pressure with the rotational motion can make different geometries. This particular lab was able to recreate the vortex, 6 sides, as well as other geometric shapes. It kind of reminded me of the physics demo, if you ever see the sand on top of the different waveforms, is that different vibrational modes induce different shapes. And so some combination of the rotation, the gas density, and the gas type was able to basically make a really strong, stable jet that's 6-sided. But again, theoretically, other gas giants might be able to make octagonal ones or other geometries. Yeah, it's really cool.
This is an interesting one. Do you have an estimate for how many comets you could fit in Texas?
Oh, wow. So they're smaller or thereabouts of some asteroids. So thousands to maybe hundreds of thousands. Because also comets start out at one size and likely break up as they orbit around the sun. So they probably start out a lot bigger when they're far out in the Oort cloud, or as we've seen recently, that some of them are coming in from outside our solar system. And so, there's probably some comets that are on the scale order size of Texas. It's also theorized that when planetary systems are formed, there's more planets kicked out than are retained in. So there's rogue planets out there. There's rogue Texas is probably out there. It's the Wild West.
All right. And then I always like to end on a fun question. Someone wants to know, where did you get your jacket?
Okay, so yeah, I do a lot of thrifting and I go to Buffalo Exchanges. So yeah, Buffalo Exchange was founded in Tucson, where I spent a lot of time and got my PhD. So this was, I think, Buffalo, Houston, or it might have been Austin. I'm slowly going to every Buffalo. Sorry, I have a bad run. But the Buffalo here is an outlet, so it's actually all like fair prices. Like everything is like all pants are $5, or all shorts are $4 or whatever. So yeah, hit up your local Buffalo Exchange for sure.
Very cool. All right, thank you. Let's thank our speaker once again. And there were more questions, I'm sure, Allison, if people want to come up and ask questions, is that okay? Yes, all right, so feel free. We'll go on our little 10-minute break here, so please return by, 7. Check, 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 check. 1, 2.
check, check, one, check, 1, 2, 1, 2, 1, 2, check, 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 check. This is a test. This is a test. Why am I on that? I didn't even need to be on there. Oh, jeez. Anyway, okay. Just needed. Still a bit fuzzy, isn't it? Is that just your... because your speaker's turned all the way up? Anyway, okay. Yeah.
All right. Oh, are we on? Check, check. All right, cool. All right, everybody. We're resuming our scheduled program. Up next, we're going to have Astronomy in the News with Jasmine Singh, and after that, our second speaker. Take it away, Jasmine.
All right. Hello, everyone. How are we doing? Let's go, let's go. We went to the moon. I think that deserves a round of applause. Yeah. So, obviously I have a time limit, so I can't go on and on about Artemis 2, even though I really want to. But, I hope you follow along as best as you could. And if not, I'm going to sum it up in the best way possible. But, these are actually my close good friends. They went to the moon. This is Rise. I love Rise. So let's get into it. All right. So I have notes on my phone now, so hopefully that helps me with pointing things out. But for May, we have a meteor shower, the Eta Aquarium, I think is how you say it, meteor shower, which actually peaked yesterday and today, so sorry about that, but I wanted to include it anyways. Hopefully you caught it if you could. But in terms of planets, Venus is going to shine very brightly in the early morning sky, and then Mars, Jupiter, and Saturn, they're going to be more visible at different times throughout the night, obviously. And then we have a few summer constellations that are beginning to rise, including Scorpius, Sagittarius, and Cygnus. So I'm going to try to point them out on here. So for Scorpius, okay, if you find Antares, which is right here, labeled on the plot, then Scorpius is around Antares. And then for Sagittarius, Sagittarius is actually slightly to the right of Antares, near the southern horizon. So also in this general area. And then Cygnus, which is the swan, you have the Cygnus star cloud, which is up here, so it's near there. So those are some important constellations that are coming. And then May also has 2 full moons, including a rare blue moon on May 31st. So it's a great time to say once in a blue moon. All right, my favorite part. So Artemis 2, I'm sure you heard about it. We took humanity back to the moon. So that was really special. And it was actually the first crewed deep space mission since Apollo, sending astronauts around the moon aboard Orion. They traveled to the far side of the moon and experienced a communications blackout with Earth. But it was also historic in other ways because we had the first woman, Christina Cook, and we had the first person of color, Victor Glover, to travel beyond low Earth orbit. So historic. And then we also had the crew witnessing a historic solar eclipse from beyond the moon. So we got a really interesting perspective because that is a rare view that we've never seen in human spaceflight because of where they were at. So this picture on the bottom actually is the moon and Venus view during the solar eclipse that they witnessed. And then obviously this picture up top, I wanted to include it because it was really inspiring for me as a woman to see another woman looking back at the Earth from, as far away as she did. So other facts about it, we have the spacecraft travel further from Earth than humans have gone in over 50 years. It actually beat Apollo 13 was the one that held the record before. And let's see. Yeah, that's about it. Artemis 2 is essentially the test mission before astronauts return to the lunar surface. So it's really exciting that we're going to witness landings in the future. All right, I wanted to have one more slide for Artemis 2. But this, I wanted to talk about more of the human side of things. Because for me, since I'm chronically online, it was really nice to see people connect with this mission and the crew. So, you know, they had daily live streams. I mean, I was watching it like it was my favorite TV show. Every single day I had it on in the background. You know, and they were just kind of like showing life aboard Orion. And I don't know if you guys are keeping up, but they had like daily wake-up songs that NASA would post online. So that was really nice. And a super special moment was that one of the craters was actually named Carol in honor of Reed Wiseman's late wife, which was really sweet. I hope you were able to watch that on stream because it was just super emotional. And they also named another one Integrity, which is after the spacecraft. They named Orion Integrity because of like the work that it took to get to this point. So those are really special moments, and these are Carol and Integrity. So if you have a telescope and you're able to look at the moon, try to identify Carol and Integrity. And then we have Rise, the mission's mascot, the little moon that I was pointing out. It was also, you know, kind of a beloved part from everyone online and quickly became a part of the Artemis 2 family. I know that I was one online to ask NASA to sell it, and now they are actually selling plushies of it, so go pre-order a Rise plushie if you really want one. And then I wanted to include a quote from Victor Glover on the bottom, which is, "You're on a spaceship called Earth." And I thought that that was a really, you know, a really profound quote to think about. Especially, I can only imagine from their perspective. So it was just nice to see how this mission really brought a lot of people together and made a lot of people excited about space again. So, yeah. All right, moving on. I told you we were not going to focus on Artemis 2, even though I want to. So I'm sure you've heard about the Nancy Grace Roman Telescope. We are actually looking to launch ahead of schedule, which is exciting. So it could, allegedly, I have to say allegedly, just because if I'm wrong, you can't come after me. But allegedly, NASA is preparing to launch it as early as late 2026, so this year, ahead of schedule, which is really exciting. So Nancy Grace Roman is actually named after Nancy Grace Roman, who is NASA's first chief of astronomy. Yes. And what it's going to do is it's going to survey huge areas of space much faster than Hubble using an enormous field of view. Sometimes it's called the wide-angle cousin of James Webb. And Roman's going to observe huge portions of the sky. Like, this is a big deal. We're not going to be focusing, you know, on narrow portions like Webb or Hubble. And this is really going to help us answer major questions about dark matter, dark energy, and even the evolution of the universe. And we are, one goal is going to be to understand the expansion of the universe as it accelerates. And then it's also expected to discover thousands of new exoplanets across the Milky Way. So this is a big deal, and hopefully it launches soon. So yeah, just thought I would share that news. This one was actually shared to me by Danielle. Thank you. I actually did not catch this, so I really appreciate it, because this is really cool. So apparently, there was an atmosphere detected around a tiny distant world beyond Pluto. So scientists discovered a thin atmosphere around a thin icy world beyond Pluto, which I think they should rename it. Right now it's 2002 XV93. Scientists are really great at naming things. So, the object is actually smaller than Pluto, so, you know, not a planet or anything. But it really surprised researchers because we initially thought that objects this small could not sustain atmospheres. So it's really weird that it has an atmosphere. So apparently its atmosphere is what they believe to have come from evaporating surface ice or underground activity. And so scientists think that the frozen gases may temporarily vaporize when sunlight heats the surface, and then that's kind of how this atmosphere forms. So this discovery could change how scientists understand distant objects in the Kuiper Belt. So it's nice to know that I guess we have another friend out there, even though it's not a planet. All right, so new organic molecules detected on Mars. That's also a big deal. So Curiosity discovered the largest variety of organic molecules ever found on Mars. And some of them are also have never been seen on Mars and might be billions of years old. So why is this a big deal? Organic molecules considered the building blocks of life on Earth. But I obviously had to put my caveat, this is not evidence of life. I have to say that, especially because the public, you know, they read those two words and they think it means aliens. No, it's not evidence of life, but it does suggest that ancient Mars may have once had habitable conditions. And also organic molecules, they can form naturally without life. So we don't know how these came to be. They could be from non-biological means, so we still have to do research on that. But it is interesting because these molecules survived Mars's harsh radiation environment. So it is interesting that they are still there. And so maybe Mars way in the past was more like Earth than we thought. So hopefully we will figure that out. All right, I wanted to end off on, you know, you've probably already seen these. I hope you have. Some beauty from Artemis 2. I just think, you know, this picture, I mean, we haven't gotten anything like that. That's a whole family picture. I hope you didn't blink. This is the solar eclipse view that we got from then, and you can see there were so many objects that people were identifying in this picture. And then this is like we got a huge family picture here because we have Orion, the moon, and then us right there. And then this one I just thought was really beautiful and cinematic in a way because we have the Earth kind of rising behind the moon. So if you haven't seen the pictures from Artemis 2, please do it. A lot of them were like taken on cell phones too, which I think Apple has the opportunity to make the best ad ever because it's just insane they were able to do this. But yeah, I think it just made it more human that way. And NASA also just released 12,000 more images from Artemis 2. So you can go on the archive and check them out. There's actually a lot of like blurry ones, which I thought those were really nice because it's kind of like we're all human. Even when you're in space, you're still taking blurry pictures. So yeah, but that's not all. I wanted to end off, I think, the best picture, in my opinion, from Artemis 2, Earthset. If you've seen the iconic one, I think everybody's seen the iconic Apollo 1. This kind of rivals that in a way. For us, you know, younger people, we were not alive during Apollo, so we didn't get to witness that, but I think now we have our own Apollo in a way, and we got a picture to rival it. And I have a quote from Christina: "We will always choose Earth, we will always choose each other." Please keep that in mind. Thank you.
Right, thank you, Jasmine. Very pretty photos. We look forward to the next Artemis mission. They're getting ready. They're already testing the landers. So just as a reminder, so the next mission, Artemis 3 is going to test the feasibility of the lander docking with the thing in space. Orion, thank you. Yeah. No. It's just because like the old terms. It's like the old to put it in the original terms. It's like when Apollo in mission 9, I believe, was when it undock the lunar module, turn it around, and then redocked it. That was the crucial last step they had to do to say, yes, we can do this, let's go to the moon. So this is the same thing, right? They do this. Once they get the yes, that means Artemis 4 to the moon. So, yes. Very good. All right, our next and final speaker is, oh, shoot. All right, well, there's these dates, as you can see. So go to those if you would like to. Thank you very much. All right. As a reminder, the phone number, but yeah, we'll go right into it. We have Austin Patridge, who's going to give our next talk. He is a geologist and a master's student for now, because he's completing his degree before beginning a PhD in the fall. So woohoo. His research, yes, that deserves a clap for sure. His research focuses on high-temperature materials science applied to lunar simulants, speaking of the moon, Apollo soils, and lunar simulant bricks, with broader interest in lunar geology, regolith, meteorites, and in situ research utilization. He is unapologetically a lunar geologist.
A non-traditional student. So straight out of high school, I went into the Navy, did a couple years shore duty. I went overseas to an island called Diego Garcia. It was just in the news recently because Iran shot missiles at it. They didn't get there, but they did shoot missiles at it. And it's an archipelago, beautiful waters. This is where I essentially got my appetite for research. I got to volunteer and help a lot of environmental science and biology researchers while they're out there. So the world's largest coconut crab is there. I got to do a bunch of sea turtle research, and I was a hospital corpsman, so fancy way of saying I was a medic in the Navy. A lot of turtles would wash up injured and dried out on the beach, and they would have me give IVs to these turtles and release them. So I got to do some medical work for these turtles. But how does a Navy medic end up in geology and with the moon nonetheless? And it really came to me after I left the military. I was active duty for 5 years, 3 years in the reserve, so 8 years of my life. And I was really doing some soul searching. I'm like, what have I always loved? Dinosaurs. Ever since I was a kid, I loved rocks and dinosaurs and fossils. And what? I'm going to go to school for geology. Maybe along the way I'll get a PhD in paleontology. And along the way, I learned paleontology is severely underfunded, incredibly political, and incredibly competitive to get into. So I kind of realized that it's probably not a reasonable path for me to go forward. But along the way, in my petrology and undergraduate geology courses, I fell in love with the mineral feldspar. So this is kind of what I'm known for around campus, I guess, is the feldspar guy. And while I'm in reading my textbooks, I learned there's a rock that is almost entirely composed of feldspar called anorthosite. And as I'm reading, I learn, anorthosite is also the main crustal rock of the moon. And that is how my journey into lunacy began, is really my love of feldspar and minerals. So, and today, I kind of want to, I think in my talk, I'm trying to bridge the disciplines here, because I know you guys are mostly astronomy. So I really love geology. You guys love stars and things I don't really quite understand very well. But in the middle, we get something called space weathering, and that's literally boiling rock and vaporizing the rock on the surface throughout our solar system. So that's what I want to try to bridge to you guys today. So vapor in the early solar system condensed, and we eventually ended up with a protoplanetary disk in our solar system. And this vapor actually, thank you, this vapor actually condensed, oh, I'm so sorry. It actually condensed into these things, into chondrules, into meteorites. And some of the earliest meteorite chondrules are called calcium aluminum inclusions, and they're actually how we date our solar system. So this is a thin section of mine. It's a meteorite. I just bought it online. But calcium aluminum inclusion, and then these things called AOAs, which are a fancy way to, amoeboid olivine aggregates. They also condensed from a gas. But these things are all beautiful textures we only see in meteorites, and that's how we know these vapors condensed. So really awesome stuff. But the big thing here on Earth with space weathering is we have an atmosphere. So we were talking about those meteorite showers earlier. We usually see streaks across the sky, and if you're really dedicated, you can go out with a magnet and hunt in parking lots or on roofs, and you can actually collect these micrometeorites, which are, smaller than the human hair usually. And a lot of times down on the bottom are some chondrules from meteorites compared against these micrometeorites. And again, all these things are incredibly beautiful. But here on Earth, we really only get micrometeorites. We do sometimes get bigger meteorites, but much more rare and much more sought after. On the moon, though, it's an airless body. So I have these beautiful gifts for you guys. The moon is airless, and we get these things called impact flashes. And this is actually a huge objective of this Artemis 2, was to observe these lunar flashes. So a lot of the Apollo astronauts thought they saw flashes, but they didn't know. So when Artemis 2 went, they were really focusing and looking in for some of these impact flashes on the moon. So this is from, Daiichi Fuji in Hirosuka, Japan. I'm sorry, I'm probably butchering that, but very focused. He posts these on Twitter all the time. Beautiful impact flashes. But again, Earth has atmosphere, so we don't see these, but on the moon, it is just a sitting duck waiting to be attacked. So, and we still really don't understand space weathering. So we've done a lot of different attempts in the past. So during Apollo missions even, we put this thing called out the Lunar Ejecta Meteorites Experiment. The results were kind of dubious because of space dust and electrostatic clinging of the dust particles, but we still tried. And then not only that, we had the LDEF, the Long Duration Exposure Facility, and MISSY-X for different materials we put on the International Space Station to really just test, how is space weathering different things in space. But we still don't really quite know. But some things we do know that we brought back because of the Apollo missions is space weathering on the moon in particular. We have, I guess, 2 to 3 main factors. So first we have solar wind, which is these really high, charged particles battering the regolith on the surface of the moon or any airless body, really. And these things only penetrate a couple hundred nanometers in depth, but they essentially amorphose and cause crystal damage to these lattices of not only crystals, but different glasses and things, and implant gases on these things. So crazy damage from radiation from the sun. And then we also get micrometeoroids, which will go in comet speeds or faster, usually, smack into the surface of the moon, and oftentimes we'll get melts, and they will vaporize and redeposit onto these crystal grains inside the regolith, and all this going on for billions and billions of years. It's really quite crazy. And then similar to solar wind, we get galactic cosmic rays, which, again, it's very similar to solar wind, but sometimes we get really energetic galactic cosmic rays, which can go do a lot more damage than the sun. So some things we see on the moon from space weathering, so these are some of the coolest rocks you'll see. So on the moon, we usually get these, almost all the rocks brought back were what we call breccias, which are just rocks that contain chunks of other rocks. And that's essentially the main rock we brought back. But breccias are cool because they're like a charcuterie board of lunar rocks. They are full of all these different fragments of moon rocks, and it's really, really cool. Next, we get these things called melt rinds. So when these things, meteorites and things smash into the moon, we get these huge melt sheets. And these melts will tumble rocks and literally coat these things in glass. It's intense and crazy. And then not only that, we get these things called zap pits. So almost every rock brought back from the Apollo astronauts, if not on a macro scale, definitely on a nano scale, have these things called zap pits, which are these tiny little impact craters on the surfaces of these rocks, which is just totally intense and totally cool. Yeah. let's see, next slide. And then here are some actual images of the regolith. So this is a paper about Apollo 11 soil. So we get all kinds of crazy things. So this thing is called agglutinin. It's kind of like the breccia rock from earlier, but it's in a micro scale of a material just fused together through an impact. Then we get these tons of glasses that form through the low gravity. We get glass beads, dumbbells, tons of different glasses and shards, really nasty stuff. And then here are some of my own images. So I've had the luck and pleasure of actually getting to work with actual Apollo samples. And on the left is one of the little glass beads in this Apollo 16 soil. And on the right is this ginormous agglutinin in one of the Apollo 16 soils that I got to work with. So just crazy, beautiful stuff. And then here's another thing that I didn't notice until I was actually going through my images. So this is another Apollo 16 soil image, just very characteristic, tons of different glasses and fragments inside this thing. But when I zoomed in on one of the glass fragments, it had a zap pit on the surface of this piece of glass, which is just crazy to me. This thing sitting in someone's locker for 30, 40 years that ends up in my hands, and now I can see this effect of space weathering. It just blew my mind. But I want to introduce you guys to what happens when things vaporize. And on the moon, there's a couple different paths through physics that it can happen, and it's debated on which one it is mostly. But there's 3 different pathways, all of them through impacts or from the sun can create this thing called nanophase iron. So when these micrometeorites smack into the surface of the moon, they partially melt things or vaporize. Yes. They will recondense, and because the atmosphere and there's so little oxygen on the surface of the moon, iron will actually condense and separate in a melt, and you get these tiny little, this is nanometer scale, tiny nanophase iron scale layers. And then not only that, this gets crazy, crazy complicated because we get solar energetic particle tracks, different melt rims, it gets absolutely chaotic. It is a battlefield war zone on the crystal, down the nanoscale in different things on the lunar surface. So again, I just briefly talked about SEP tracks, but we also get ion sputtering. So these highly charged ions will smack these crystals on the surface of the moon. You get all these crazy, nasty tracks. But oftentimes, it's very similar to, if any other geologists in the crowd, it's similar to apatite fission tracks. We'll actually date rocks and things like that based on the fission tracks of decaying radioactive isotopes inside apatite. Very similar. But we also get gases that are implanted from the sun. So this is an evolved gas experiment done in the 70s or 80s. As they heated up lunar soil, they measured the gases that came off, and they were better able to understand what is actually trapped in these crystals. And then not only that, this nanophase iron and space weathering really affects the spectra. So this is probably more relevant to the astronomy audience here. So on the top in a green line, I plotted just a terrestrial unweathered basalt. I pulled this from was a PDS on geosciences. I just plotted it earlier. And when you plot an Apollo 11 soil, these things are like entirely different, though geochemically they're almost the same. So when we look from Earth with our spectrometers, or honestly even satellites, we're really never seeing the true rock or mineralogy of the surface of the moon. We're just seeing this optical skin masked by space weathering. And then not only the space weathering on the moon, but on airless bodies. So asteroid Bennu, we just brought back OSIRIS-REx and everything. We've seen some crazy, again, these zap pits on the surfaces of minerals we brought back from Bennu, melt sheets and I guess the little impact melts inside these crystals, and then we also get nanophase iron, but they actually have a big sulfur component attached to it as well. So it's a very geochemically and mineralogically controlled by what is actually being impacted. Moon is different geology than a carbonaceous asteroid. So really cool stuff. And then this is something I noticed earlier because I'm about to show you guys this kind of cool, when I was doing my research about space weathering, Keller, Lindsay will come up here in just a moment. So they also were the main author that published this paper, which is a coincidence. I thought was pretty crazy. So there's a huge debate in the space weathering community is basically who does it more? Are impacts and vapor deposition the most dominant feature creating these amorphous layers and tracks on the surfaces of crystals and moon rocks? Or is it solar wind and cosmic ray damage that's really doing the battle? So this kind of does a great job, I think, just kind of animating the image here. So again, huge debate. Is it impacts or is it the sun that is really doing this damage? So in 1993, Keller and Mackay released this paper that said it's mostly vapor deposition. And, thank you. I loved the paper. It was a great paper. But less than a year later, I'm going to butcher the name, Bertonowitz came back and said, no, the solar wind is most dominant. You're wrong. And he based that on his measurements on ilmenite. So then less than a year later, they came back, Keller and Mackay, and they said, no, you're wrong. Ilmenite is unrepresentative of the regolith, and it's actually vapor. And then they came back again that same year in this technical review paper, and they both agreed to disagree. It's totally the craziest literature battle I've ever seen and ever read. And then 3 years later after that, they said it's both. It's the sun and impact vapor. And that's essentially all I had for you guys. Hopefully I didn't take up too much time. I think space weathering is really one of the coolest things ever, and it's really a discipline bridging gap here. It's, not only do you get to see geology and rocks, but we get to see these rocks vaporize and melt, and all that just totally interdisciplinary and beautiful. Again, on all bodies that are airless, and then honestly, you could argue space weathering on Earth in some aspect. And then if you're curious, since this is an astronomy audience, if you want to get involved, if you have a 4-inch or larger telescope that's digital, you too can help NASA and track these impact flashes like I showed earlier. So I just put the QR code up there. But NASA wants citizen scientists to try to image and figure out where these impact flashes are to really constrain how the flux and how much the moon is being impacted. But that's all I had for you guys, so thank you so much. I guess questions or?
Great talk. The first question I have for you is, so the objects that would cause those impact flashes, thank you, Aaron.
Yes.
Reminder for the number for the folks. Do they pose a threat to the astronauts that would be on the moon?
Oh, absolutely. So my understanding is a debate online. Artemis is still going through the data, but for the astronauts in the Orion capsule to see a flash, they've done some rough calculations, and to see a flash like that, it had to have been at least a couple kilograms in size. So absolutely, a kilogram-sized object going, comet speeds on the surface of the moon would totally mess you up.
Ouch.
Yes.
This is an interesting question.
Sure.
They say, if geo means Earth, is it still geology on the moon?
Oh, no, that's a great question. I would argue the Earth and Moon are pretty connected at this point, and we think we found some Earth meteorites on the surface of the Moon, and we found tons of lunar meteorites on the surface of the Earth. So I would argue at this point that they're one and the same.
How do gases become trapped in rocks?
Oh, okay. So gases trapped in rocks. So a couple different ways to do that. So just naturally through volcanism, there are oftentimes the main volatile gas that drives volcanoes, and oftentimes you can trap these gases in vesicles inside rock. But in the case of space weathering, it's that ion sputtering. So these charged ions are being blasted off the sun, and I showed it's mostly hydrogen and helium, but we do get argon, nitrogen, carbon, tons of other elements that get implanted. But essentially these ions are smashing these crystal faces, damaging them, making room for themselves. So then all of a sudden this hydrogen ion becomes a hydrogen gas molecule attached to that crystal in that spot. And billions of years that adds up.
How does one procure Apollo samples to study?
Oh, yeah. It took a lot of research, and you essentially have to write a proposal that is justified. So you have to essentially be under already a funded grant or problem, and you write a proposal very well selecting your samples that you want and why. So you send that to NASA, and there's a curation team that reviews it, and they tell you yes or no, or they might even change your samples.
All right. The people want to know, what's the big deal with feldspar?
Oh, sure. Yeah. So with feldspar, I think it's just, it's the main terrestrial or crustal mineral here on Earth. And to a lot of people, when they look at a rock, they get really confused. They don't know the minerals they're seeing. But most of the time, it's got a little bit of feldspar. So most of the time it's feldspar. When you look at it in the microscope, it almost always looks the same. And on Earth, one way we define rocks is usually by the minerals they contain and how much of those minerals and their textures. So on Earth, we have something called QAP. It's quartz, alkali feldspar, and plagioclase feldspar. And 2 of those ends are feldspar. So if you know what feldspar you're looking at and how much, you could probably define most rocks here on Earth.
Is there a way to differentiate different space weathering methods?
Yeah, so it's kind of tricky. So the main arguments in those papers I was citing, they were mostly based in geochemistry, and I'm certainly not an expert on how these vapors fractionate and deposit and what goes where and why. But that is the main crux of their arguments, is that these geochemical signatures that they're leaving behind had to have been, really, really fast, and certain elements that want to be, blasted off into the vacuum of space will do that and volatilize, while others will stay.
How often do you wear your astronomy hat versus your geology hat?
My astronomy hat is very tiny and broken, so please come school me, any astronomer out there. I will love to hear anything about the sun or anything you guys want to chat my ear off. I know very little, so I wear a geology hat most of the time.
All right, and then the last final fun question. What's the most lunatic moon fact / or probably conspiracy that you've been told?
Conspiracy?
I guess I don't know how often you go around and interact with people, but what is the thing that
Yeah.
I mean in the professional /
Other than outright like moon landing denial, I've heard a couple times online that the moon rocks are fake, and they say the moon rocks are fake somehow, and they're all lunar meteorites. But it's the other way around. We only know lunar meteorites are from the moon is because we had the Apollo missions and we brought those samples back. Yeah.
Gotta watch out for fake rocks.
Yeah.
All right, let's thank our speaker once again.
Thank you, guys.
All right. Perfect timing, because we'll spend around 5-ish minutes preparing for our trivia here. If you cannot stay for trivia, we thank you so much for coming tonight. We'll see you all for the June edition, which I don't have the date off the top of my head, but we'll see you then. First Wednesday of June. Stick around for trivia. And a reminder about shirts. We'll see you. Reminder about shirts. If you haven't gotten one yet, come on up. don't know why I closed this. I just closed my pen. All right, reminder, groups of 4, multiple choice, only write the letter. Don't use your phones. Let's stay fair and square. And yeah, hey, that counts as the phone. I don't know where else you're going to get the AI from. Hey, more power to you. If you put that in your brain, then good luck. Good luck. You're probably not long for this world. How about them Canes? They haven't lost a game yet? Hey, okay, fine. Neither has Colorado. Neither has Colorado. So there we go. All right. Aaron, you ready?
I am ready. Question 1, magic or science? In Harry Potter and the Prisoner of Azkaban, this wizard can be seen reading what famous science book? Is it A, How to Build a Time Machine, B, Black Holes and Time Warps, C, Cosmos, or D, A Brief History of Time? Does that mean Harry Potter is like a different, it's like a multiverse thing? Yeah, yeah. I never really thought about that.
Okay. We'll move on to question 2. Breaking records. Before the Artemis II crew broke its record, which Apollo mission held the record for the furthest distance traveled from the Earth? Is it A, Apollo 8, B, Apollo 11, C, Apollo 13, or D, Apollo 17?
Memory recall. Jasmine did say it. All right, question 3. Press AZ5. In nuclear physics, what word means the rapid emergency shutting down of a nuclear reactor? A, entomb, B, scram, C, void, or D, burn up? What a random question. I watched Chernobyl. Yeah.
Okay, question 4, sticking on the nuclear theme. Radioactive or stable? Which element in the periodic table has the highest number of stable isotopes? Is it A, iron, B, tin, C, tungsten, D, gold, or E, uranium? Which one has the most stable isotopes? Stable means that it can last for a long time?
Probably a half-life of like
Probably, yeah, I mean, yeah.
half-life of like thousands to millions of years.
Yeah.
It's just so many times the order of magnitude of the age of the universe that it.
I would say half-life longer than civilization.
Uranium would be stable by that.
Really?
Yes.
Oh, I thought,
Uranium to date, zircon.
yeah. Yeah.
Sam doesn't think of these things. Go with your gut. You know, just go with your gut. Sam's favorite. Finish that lyric. Following its resurgence after Project Hail Mary, Sign of the Times by Harry Styles. Just stop your crying, have the time of your life, breaking through the atmosphere. Is it A, things look pretty good from here? B, we got to get away from here? C, they told me that the end is near? D, overcoming all of our fears? All our fears.
All right, question 6. My elbow after a nap. This image, taken by NASA's Juno mission, is the highest resolution photo ever taken of which Jovian moon? Is it A, Europa, B, Ganymede, C, Amalthea, or D, Enceladus?
All right, does anybody need a question repeated?
1 through 6, is everybody good? All right, bonus.
Bonus question. The bonus question goes in the bonus section because that's where the bonus question goes. If you watch the Apollo 11 moon landing live, write yes and receive 1 point. Also, come up with a name for the mission to Mars. Most creative answer awarded plus 1 point. Oh, come up with a name for the, like a human mission? I'm guessing a human mission. So like Apollo, Artemis. Yeah. Allison, when you are done with your trivia sheet, if you would please bring it up to us along with the pen if we gave it to you. We're poor. We need our pens.
Is anybody not turned theirs in yet?
after a debrief. We have our answers. Name that book in Harry Potter, Prisoner of Azkaban. A Brief History of Time.
Yes, because I said that one because Stephen Hawking is British. That's the only reason I said it. I figured that, you know.
I said it because of the size of the book. But that doesn't make any sense.
All right. Which one broke the record before Artemis II of the farthest from the Earth? And this one was by accident / fortune that they made it back home. It was Apollo 13. They weren't supposed to do such a wide slingshot, but they had to get back home.
Screenshot engage. All right, question 3, press AZ5. What's the name? Scram button.
Scram! Get out of here! Scram!
What is Chernobyl? Chernobyl fans? Well, the show, not the event.
I love a good old meltdown. I know you do too, Danielle.
What?
A good nuclear meltdown. All right. What's the most amount of stable isotopes for one element on the periodic table? And the answer was tin. And that just goes to show you that the Tin Man always had a heart. Yep. I know, right?
So what, his heart lasts a long time? Okay. Just look it up, okay? Just look it up. Because I did it, just look it up. It's A, question 5. It's A. It's a different, it's different. The part that Sam picks.
Oh, that makes sense now.
I think she's saying the whole song.
She's saying like 2/3 of it. No.
No, it is, but not without the two. Like each one happens. It's just, they're different verses and like it changes throughout the song.
Once again, Samuel Hart Helio
I will say this
at gmail.com.
was a good question.
No, I agree. I'm just in general, Samuel Hart Helio at gmail.com.
This email statement.
All right. The next one was about that feature on the ice that some of us call the platypus. You tell me if you see it or not. Some of us call it the platypus. It's on Europa. See, Pippa's nodding her head, right? It's the platypus.
If you scream at me platypus while I'm looking at the picture, yes, I will see a platypus.
Now, the question is it Perry the platypus? That's the question. No, it's missing the hat. It's missing the hat. Yes, this is on Europa. This was a fortuitous flyby, and they actually got this image with the star tracker, right? Wasn't this? Yeah. This was the star tracker of Juno because it's meant for low light, so it got this really high contrast, because ice, high albedo, right? Yeah. Yeah, well, I mean, Juno is a spinning spacecraft, so it's got a lot of these trackers. So this was just a particular. I don't know. Well, okay, Europa's radius is like 1,500 roughly kilometers, something like that. Fraction of Texas. Wow. Okay. Bonus. Well. Well,
And then the most creative mission name, Meltman. It's an acronym. Let me read it for you. Martian evaluation for lava terrain for melts from Amazonian to Noachian. I appreciate the acronym.
we love a good backronym. We love a good backronym. All right, prizes for this evening. We have a tie for third between the Starmaster and HP 8974-2026 APYZ. All right, come on up. All right, well, they get their stickers. In second place is the group that gave us our lovely winner of the Creative Meltman Prize, the Psychics. Yeah. I see what you did there. Some nice postcards. And then our first place prize tonight is, Aaron, you want to show off it's this very pretty WMAP poster of the cosmic microwave background. And we picked this because this is the biggest scale. This is the entire universe right there. That's it. Doesn't get bigger than that. That's a lot of Texases, right? That's way too many Texans. I think we're going to need what's that number, that big number? No, the tree threes. Any math people in the house? Even bigger than that. The winner tonight, App J. Come on up. The Astrophysical Journal. I'm glad the Journal could be with us tonight. The Journal, provides us with such great... It's actually a good journal because it's open source. You can go look up any AppJ article for free. Huh? Real? Oh my God, yeah. That's a good one. Damn, that's a good one. Yes. All right, where's our clicker here? Thank you again so much for coming. The next AOT will be on June 3rd, so join us then. We'll have some more great speakers for you then. And make sure that you sign up for our email list if you haven't already, and we will see you then. And if you haven't gotten a shirt yet, you can let us know. Even though we've packed up, we'll grab one for you. If not, you can wait till next time. Totally fine. Good night.